Thank you for being here in such a late hour of this day. We are going to talk about AI, which you probably heard already today. So what we are seeing today is that the world is focusing and pushing to have AI everywhere. We saw it today in all the lectures, and we will talk about a bit of it now. And there is a high demand in the market to bring AI into production. And the question that we ask ourselves is, how can we take this unfamiliar technology and bring it to production? So we see in the surveys that have been done that companies already increased the budget to use AI. We see that the AI market will raise from $5 billion to $50 billion within 5 to 6 years. And we see that IT leaders are saying that they already implemented AI and are going to invest more money in AI. So AI is everywhere. And we, as DevOps, need to answer those questions. How can we take this unfamiliar technology, bring it into an environment which should be mature, maintainable, and keep high SLA environment? And this is something that we will show here today. So here with me is Benji Kalman, the VP and co-founder of Root.io, with 15 years of experience in the security area.
Thank you very much. And of course, here with me is Shiran, who has over 20 years of experience in DevOps leadership and is the group leader of the DevOps group in JFrog.
Thank you. Great. So let's speak a few seconds about JFrog, because eventually I'm from JFrog. Who here is familiar with Artifactory? Woo! So Artifactory is a tool that JFrog created when she was first founded in 2008. And the challenge in the industry back then was managing binaries and images, and Artifactory solved this issue. But with the years, there were many other challenges. For example, security, lifecycle, machine learning. So today, JFrog is not one tool company. It's a full platform that handles the lifecycle of the application from the moment the developer committed the code till the moment the code ran in production. And just lately, we created JFrog Fly. JFrog Fly is an agentic AI, an MCP server that helps you communicate with your private registry. So now you can ask your registry, what is the latest release that is secured and I can use? And the JFrog Fly will answer. So if it is interesting, please scan the QR code and you will reach the page.
Cool. And I'm not going to do the hands up thing, because that's the problem with coming from a small startup. If I were to ask you guys, who here's heard of Root? The two people here from my startup would raise their hands and no one else would. So instead, let me tell you what Root is. So Root is a platform that we use to basically what we call agentic vulnerability remediation, where we take input, and the input is containers or packages, and we scan and identify all the vulnerabilities, just like JFrog does, and we partner with SCAs who do this. But the thing that we do, which is one step further, is we go ahead and we remediate agentically all of the different vulnerabilities that are identified in the open source components inside that image. And we're going to be talking a little bit more about that as part of this talk. So this is just a little spoiler to begin us off with.
So what is an agent AI? We will go through quickly just to align everyone, and because my metaphor is really, really good, so I have to show it. So you have a chef that is getting a recipe. You have a predefined instructions. He will work according to those instructions. Probably you remember the chef configuration tool that we used to have in the past. And the agent AI chef is getting the ingredients. He's thinking by itself what he can cook with those ingredients. He is cooking that, and then he can change things. If the outcome is not good enough, he will change it and he will recook. So the AI chef is not working according to predefined rules. He can change the outcomes. He can take decisions to get better results. He is learning within time. And this is the difference between the regular chef and the AI chef. And in our scenario today, we will focus on security vulnerabilities in open source packages, something that is very familiar and very known in the world today. Just a few weeks ago, we had the largest NPM attack where a lot of open source packages were compromised. This is a short list that shows those packages. So this is the scenario that we will focus today, but of course, we can take the example that we will show today to any other example that you need. So now when we have compromised package, what we need to do, we need to find a new package or a new version that will not have this vulnerability. So we need to research and see if there is something like that. We need to code it, to put the new package in our code. We need to pack it again. We need to test that everything is working and to deploy to production. Eventually, it can take between 14 hours to 75 hours for one process, which is a lot of time and resources to invest only in one package. So what we can do, you can scream it. We can use agent AIs to reduce the time. So Benji, how we will do it with the AI?
What a great question. So how could AI agents help fix a CVE? So let's start with the basic, what we all do today. We have an image, we have a package, we scan it, we get our list of CVEs. Again, nothing here is particularly new. And then we have, obviously, all of the applicable fixes. So if you're talking about a world, say, your container's a Debian bookworm or something like that, and Debian have released a version specifically that's compatible with Debian bookworm of your libcurl package, you can probably safely upgrade to that and not fear for any breaking changes. But the question then happens, what happens when there aren't applicable fixes found? So this can be, say, all right, so libcurl, the maintainer upstream, has released a fixed version. Debian have deprioritized ever fixing that. You have a critical vulnerability, and you're stuck. Or it's an application, you're on some kind of version, some version of Lodash. There might be a fixed version in some other major branch, but you're stuck because you can't go there without breaking everything. So here, basically, we need to begin a system of researching and identifying where any type of fix could be found for this vulnerability in the wild. And that we would have a first set of fleet of agents that would be able to do that would be able to research, trawl all of the various places that we think there might be an applicable version and identify it. Then we'd hand that off to a different set of agents who would basically create this fixed package. So again, they would need to do quite a complex series of things that would have to happen. If everyone here probably is using AI in some ways to code and create changes, you know that it's difficult to get Claude Code or Cursor or anything else to fix something simply. You need something quite complex to be able to be applied to any package anywhere in the world. And then finally, you would need to then test it and verify that you were actually able to build this without breaking absolutely everything to go onwards. And ultimately, you would end up with your fixed image with every single one of the packages fixed. So that's how we could solve one. But the question is, how do we go from one fix to 1,000? So if we're scanning a single image and we want to, there are hundreds of vulnerabilities that need fixes in it, or if we have the ambition, as we say do at root, to fix everything inside the open source, how do we go from 1 to 1,000? And the answer is orchestration.
So with orchestration comes the requirements. So we need to change things because now it's not only one process. So we need one centralized place to see all the processes, observability, logging, to see that everything is running correctly. We need error handling mechanism, a retry mechanism, so processes will not fail and we will not know about it. Dynamic scaling, of course, we need a lot of CPU and memory to run all these processes, as we need to have it scaling by itself dynamically, so we won't waste also money. And we need rapid deployment and rollout, so we will have it, again, fast and at scale. And human gates, maybe we want to add human approvals into the automatic process. Let's speak about it a bit more later. And of course, chaining tasks, because we have now few processes, maybe we have few agents, so we need a tool that will support this as well. So before we will show how we answer those requirements, let's understand when typically we will use Argo Workflows. So when we have a complex multi-step a workflow, Argo Workflow will work very well. Container isolation, we have a container with its own context, with its own resources, and of course when we want to scale, when we need to run many processes at once. But Benji, how does this meet our requirements?
So now let's just zoom in a second on Argo itself. And we've done a comparison here to some other tooling such as Apache and Jenkins. But for the usage of time, I'm just going to concentrate purely on the line of Argo CD and Argo Workflows and talk about how it meets the requirements of what we're trying to set up here. So one of the things that we need is observability. Obviously, if we're going to be running thousands of different agents running across different places, we need to have a single place where we can have that. A unified UI, Prometheus and Grafana having native metrics makes this a very simple process with what we're doing here. In retries and error handling, we have these exact things that we can configure per workflow, the retry mechanism. This is important. Potentially, as we said, an AI agent could go haywire. It could provide us with bad results. We want to be able to know how many times we're going to retry running that and not waste all of our hard-earned cash. Talking of hard-earned cash, we want to be able to dynamically scale up and down. That's something, obviously, Kubernetes in general, but Argo is very useful for. Using stuff such as Carpenter is something which makes it very easily using spots for us to quickly scale up when we have a sudden spike and to scale back down again. GitOps, easy for us to sync, roll back, roll forward. This is really important for us, especially as we want to be able to be dynamically experimenting with many different agents all over again and many different models that we want to be trying out. And human approval gates, the fact that we can have suspend and resume steps, means that we can add those humans in the loops. And obviously, we can, using DAG, we can chain tasks and have conditional logic involved. So all in all, this is something which meets the requirements that we need that you probably could have guessed from the topic of the topic that we're talking about. So let's dive in a second. What then is the mechanism to use from an infra point of view that we can use in order to do this? So what we've implemented is a three-stage system. The first is simply the Argo CD layer. This is the layer that we use that deploys the template, the workflow templates, and the cron workflows that we're using. It manages everything that has to do with RBAC and secrets. It manages the Carpenter node pods. And it also allows us to do GitOps syncs per environment, just like everyone else using Argo CD out there. The second layer that we have is our workflow. This allows us to execute the research agent containers. We're going to have each one of our agents run inside its own isolated container. This is very important to us, both so that it can be unpoisoned and uninfluenced, and also because if you're building packages, you have all kinds of requirements that need you to be able to quickly build up and spin down containers. We're going to be using DAG, and we're going to have S3 artifact persistence for us to be able to store things continually, and we're going to use Jira integration for ticket automation. And then finally, we have the Carpenter layer. This allows us for just-in-time node provisioning, instance optimization, and consolidation. So all of this is everything, these are the three layers. Let's dive in a second into that Argo's workflow layer to understand a little bit more what that looks like. So inside the Argo workflow layer, let's give you a little bit of a cookbook here for how we are running our AI agents. We here again have three different layers, just because I like the number 3. So the first thing that we have is the CV research orchestrator cron. This orchestrates all of the other runnings of the different workflows that we have. And this enables us to do, we call upon this 2 different times. We have both a daily recurrent cron that runs and spins up all of the different agents that we might need to solve all of the as yet unfixed vulnerabilities that we might have inside our database. And also every time we have a new input, i.e. we scan a new package or a new image, that also orchestrates and spinning up all of the different workflows. The second layer that we have is the CV research template. This is a DAGs. It has two kind of simple steps here, which is to execute the research agent itself, which is what it's going to go out, do all of that different research, identifying fixes, testing all of this, and eventually it's going to post its results into Jira inside a ticket, and also into we use GitLab specifically. It's also going to open a GitLab MR for us to be able to review. And then finally, we have the research agents template. This has the tools which are defined and called by the DAG, and it has a very simple input and output that we're going to go into a little bit more.
So let's get into the CV research and see the parts that we have there. So the first part is the inputs and the outputs. The input comes from the previous process, like the CV ID, the package name, the package version. Those are coming from the database after the previous process has inserted them. We take it from there. This will be the prompt for the agent. We will put those parameters in the prompt. The output will be the research summary. So eventually, the input and the output need to be predefined because this is the contract between the two processes.
The second thing that we're going to zoom in here is, for a second, is the environmental variables, or the end variables that we're using. So some of these are pretty obvious to us, right? So like obviously which environment we're in. So this we took from our development environment. And there's other stuff here which we've given to the agents as the match, such as the max scrape size, which is a number that we've given the agent in order to limit it. How many times exactly it will scrape the internet? Apparently 80,000 times. Other than that, a few other things which are important to note here is simply just that we're using models as variables as well. And you'll notice that we have several different models because several different parts of the agent are going to be using different models in order to do different tasks, because some of this is for cost saving, some of this is about just optimizing for what is a better usage of each model. And these, again, are easily defined as variables and can be easily switched in and out, and again, allow for experimentation, which is a very important part of what we want to be able to continue to maintain.
And another important part that we can see here is that inside this process, we have another image. So this image is another workflow, Benji?
Yeah. So one of the things that we're doing is we are calling a container which has a full workflow inside itself, which is doing many, many, many different things. So you don't need to strain your eyes too much to go into this, but I just wanted to show off with how complicated this workflow is. And it has various different steps here. It has its primary research, a secondary research, it's optimizing, it's schmoptimizing, it's doing all of these different things out there in order to get the best possible result. But the thing to take away from this, because we're not talking about agents here, but rather we're just talking about how we should be orchestrating and running agents, is trying to answer the question, workflows in workflows, does that make sense? Because we're talking about using Argo Workflows, which has its own predefined steps, and we've just been talking about how useful it is to call different steps and using DAG and all of this. And inside the middle of that workflow, we're suddenly calling on an entirely other workflow, which is doing its own thing. So we might ask ourselves, why do we need anything to do with the Argo workflow at all? Why isn't all of this an agent that we just have running do all of the various different things? Or we could ask ourselves, why do we even need the agent? Maybe Argo should simply be doing this. So I think we answered why we do need the agent with the beautiful chef analogy, but I think we can also talk about why it is that it makes sense for us to have this separation of workflows in workflows. So the first thing, and this is very important for us, is the separation of concerns and teams. So I'm VP of engineering, so I have to hire different people to do different roles. And my AI engineers have different capabilities and different responsibilities to my DevOps team. And they are better at different things. And this is important for us to be able to understand. We want to maintain that ability to have different teams and different people owning separate parts of the system. And we want to have, therefore, clear contracts between these workflows. So we've stressed this a couple of times, the clear contractual inputs and outputs that we have between when the agent begins and when Argo takes over. This isn't different from the type of methodology that we've been using for years between front end and back end, and having clear API contracts between these different teams or between different back end teams. So we want to be able to continue and maintain these contractual obligations as long as we have clearly defined inputs and outputs. This allows us to experiment as much as we want inside of that agentic world, for that to change as much as possible, while still not breaking production, always a good thing. The other thing that is important is there is a difference in monitoring between workflow and between workflows and AI. There have been some talks today about OpenTelemetry solving absolutely everything. I don't yet believe OpenTelemetry solves absolutely everything in the AI agentic world. And more than that, I think there are different things that you want to be doing when you're monitoring for AI agents. Things such as LangFuse and LangChain allow you to step in specifically into a certain part of the stage of when an agent has been run and to change things. That's different from the type of monitoring that we might and alerting that we might need as part of Prometheus and Grafana, which is a different separation of concerns that we want to be able to maintain. And finally, and again, if you literally don't listen to anything else we have to say, please take this. Don't believe the hype. Use AI only when necessary. AI is a great tool, but the technologies out there are not battle-hardened in the same ways that others are. A lot of it's written in Python. That's less efficient for us than things which have been written in Go or Rust or C. And it simply just doesn't. It's still immature and developing technology. It's amazing technology. I love it. We built a company around it. But it can't do everything. So only use it where absolutely necessary. If you need something which is simply going to write something into Jira or open an MR, AI doesn't need to do that. There is already technology which has been proven that can do that repeatably and efficiently. Where you don't have things which can be predefined and configured, use AI. Elsewise, use Argo.
Great. So we saw how we solved the challenge. We have now a way to solve the security vulnerability at scale for more than one process, but still we have challenges. So first is scaling limitation. Even if we will take the obvious limitation of cloud providers, the infrastructure is off, we don't have any more EC2s. Even if this limitation was endless and cloud providers would supply us endless infrastructure,
US East 1.
Still, we have third-party components like database rights that will limit us eventually. So this is one of the challenges that we are dealing with. Second, and we reminded it before in our requirements, approval gates. So we need to take a decision if we want to interfere in the automation, where do we want to interfere, how much flexibility we want to give to a human being in changing the automation or interfering in the automation. So this is also something that we need to decide about. And the last one is context hands-off. So Argo is giving us isolated ephemeral containers, which is great, and we use them to run our agents. But in a multi-agent system, when one agent needs to know the context of the other agent that was executing, it's a bit of a problem when they are isolated and they don't have this shared context. Let's take, for example, a testing agent that failed to pack an image. When it goes down, it spins the next agent, and that agent needs to know what was the error that failed the other process so he can effectively fix the issue. So today, we are using MD files as a constant shared context. But eventually, we will need to move to a more mature solution, maybe like a VectorDB or other solutions that we have today. That's it. If you have any questions or if you want to give us feedback.
Or just tell us how beautiful we are.